Okay, ladies and gentlemen, let's start with something pretty basic. That right there is a point. Okay, ladies and gentlemen, let's start with something basic. We have a single point right here. I'm going to call that point A. Now, if I put a second point on here, and I'm going to call it point B. The most basic thing in the world that we can have is a point. So we have one single point, and we can call it point A. But as soon as I start putting 2 points down, then I can connect them, and that becomes a segment. So let's make a segment. And we went from no dimension to one-dimensional, left and right. Now, if I were to extend that point, or extend that through the point, I would come up with a ray. And if I extend it in both directions, I come up with a line. But all of these are just variations on a theme. They are all just a point times a point by 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 a point, and strung together, either from one place to another or all the way to infinity. Now, these would all have to be co-linear points, because they would have to be co with line, on the same line. So these are all collinear points. Now, as soon as I take and I put points out of the way, so I have my 2 points and I put another point here, I create an angle. So if I have this angle, we already know that that angle can be small, so it is acute. We know it can be right at 90 degrees, or it can be obtuse. In fact, it could even bend all the way around and go exactly opposite directions and be a straight angle. But in this case, we have something that is either no dimensional or one dimension. Here we start moving into 2 dimensions. And for now, that's where we're going to stay, is in 2 dimensions. So let's return to our point. If it's not collinear, that would be not on the line. So let's put a point right here. If I put a point right over here, I can connect it with one piece, and that is an angle. But if I connect all possible dots with their neighboring dots, I now have a triangle because it has 1, 2, 3 angles. And so when we move back over here, underneath 2 dimensions, we can move in 2 dimensions but have 3 parts to it. In this case, it's a triangle. So underneath triangles, we have triangles that have all small angles, so those are acute. Then we have right. Then we have obtuse, because we have an angle that is bigger than 90 degrees, so obtuse. And of course we have scalene. We also have isosceles, and we have equilateral. And so all of those we're already familiar with. And of course, equilateral is also equiangular. So equilateral and equiangular. So we have triangles. So that is using 1 point, 2 points, and 3 points. But as soon as we move away from 3 points or 3 parts, and we move to 4 points or 4 parts, now we start to work in a different series. If I take a point and I literally put it anywhere on this page, let's put it over here. And I now connect any adjacent point. what I've just created is a four-sided figure. And so that four-sided figure becomes a quadrilateral. So 4 parts is quadrilateral. And there are a number of different types of quadrilaterals that we can go into. But for now, let's move to 5 parts. As soon as I move to 5 parts, that means I put a 5th point anywhere around here. So let's put it out here. And if I connect the adjacent points, I now have a 5-sided figure. But what you'll also notice is that with 3 sides, I have 1 triangle. With 4 sides, any 4 sides, I always have 2 triangles. And as soon as I move to 5 sides, I have 1, 2, 3 triangles. This is something that's going to hold all the way to infinity. And the nice piece about this is no matter, by adding 1 point, I add 2 sides, and I add another triangle. So that gives us a great formula that we can use when we start talking about polygons, which are, of course, many-sided figure. Polygons, if any triangle contains 180 degrees, 60, 60, 60. If this triangle contains 180 degrees, here, 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 and this triangle contains 180 degrees, here, 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 and here, and here, and every time I add a point, I add another triangle and another 180 degrees, what you will find is that however many sides there are, we simply subtract 2, and that is the number of triangles. If we take the number of sides minus 2 times 180, that is the number of degrees in a given figure. So, for example, in a 3-sided figure, 180 degrees, because 3 minus 2 times 180, 3 minus 2 is 1, 1 times 180, 180. In any 4-sided figure, we're going to come up with 360, because it's 4 minus 2 times 180. In a 5-sided figure, we have 5 minus 2 times 180. We come up with 540 degrees. And it continues on because as I add a side, all I'm doing is adding one more triangle to the mix, and that adds another 180 degrees. So polygons are nothing more than a conglomeration of extra triangles created by simply adding a single extra point. And every time I add that single extra point or a single triangle, it creates another 180 degrees inside the figure. Now, there is one other thing we need to remember. This is interior. If I want to go around for the number of degrees exterior, that's on the outside. So I wish to walk around this figure exactly once. Well, if I go around it once, it's going to remain constant at 360 degrees. So, when we start talking about quadrilaterals, we have lots of names, like parallelogram, trapezoid, or rhombus or kite or a number of these things. But when I get to 5 parts and beyond, I have only 2 types, regular and non-regular. Regular figures have all sides and all angles that are congruent. So the pentagon, as seen as the Pentagon in Washington, D.C., versus non-regular, the pentagon seen at home plate, or literally in everyone's drawing of a house. So we have regular figures and non-regular figures. If I wanted to know what the inside angle of every regular figure would be, I could simply say sides minus 2 times 180, and then divide it by the number of sides, and that would be each interior angle. So those formulas are important, but what's most important is to understand that every polynomial is nothing more than a series of triangles. If I have a polynomial that looks like this, I can name this polynomial 1, 2, 3, 4, 5, 6, 7, 8 sides. It's an octagon. I can say that there are 8 minus 2 times 180. So 6 times 180 would be the number of interior angles. I could say 360 is the exterior angle. I could not give each interior angle because this is a non-regular octagon, but this octagon is not really made of 8 sides. It's really simply made of 1, 2, 3, 4, 5, 6 triangles. So triangles make up all polygons. And so everything we do for polygons is going to be based off of triangles until we talk about area or volume, and in which case we'll start talking about squares.